Welcome to Machine Learning Training Bootcamp by Tonex Training. Machine Learning Training Bootcamp is a 3-day specialized training course that covers the essentials of machine learning, a shape and utilization of man-made reasoning, AI. Machine learning computerizes the information investigation process by empowering PCs, machines and AI to learn and adjust through experience connected to particular undertakings without unequivocal programming. Participants will learn, appreciate and base thoughts on machine learning ideas, key standards, and methods including managed and unsupervised learning, scientific and heuristic angles, displaying to create calculations, forecast, direct relapse, bunching, grouping, and expectation. Learn contrasts and likenesses between machine learning, artificial intelligence, and data mining. Man-made brain power utilizes models worked by machine learning to make savvy conduct connected to organizations, showcasing and deals, activities, self-sufficient autos, recreations and modern robotization by prediction in view of guidelines and utilizing programming dialects and calculations. Machine learning based on artificial intelligence provides the ability to learn about newer data sets without being programmed explicitly using methods of data analysis. Machine learning takes advantages of data mining techniques, statistics, other key principles and learning algorithms to build models to predict future outcomes. Math and programming are the basis for many of the machine learning algorithms. Using machine learning as a tool, the machine must automatically learn the parameters of models from the data. Using larger datasets, better accuracy and performance is achieved. Machine learning and data mining can use the same key algorithms to discover patterns in your data and dataset. In machine learning, the computers, machines and AI devices must automatically learn the parameters of models from the data using self-learning algorithms to reveal insights and provide feedback in near real time. Machine learning, for example, can be used in proactive maintenance to continuously monitor the performance of simple or complex industrial systems, applications and events. Using the ability to learn and adapt makes it the optimal choice for improvements in ongoing processes, and to automatically predict and prevent failures. Learn how machine learning can automatically process and analyze huge volumes of complex data. Machine learning powers innovative automated technologies such as recommendation engines, facial recognition, financial losses from stock market and bonds, fraud protection, self-driving autonomous cars, robotics, industrial automation and future applications. Learning objectives. Learn about artificial intelligence and machine learning. List similarities and differences between AI, machine learning and data mining. Learn how artificial intelligence uses data to offer solutions to existing problems. Explore how machine learning goes beyond AI to offer data necessary for a machine to learn, adapt and optimize. Clarify how data mining can serve as foundation for AI and machine learning to use existing information to highlight patterns. List the various applications of machine learning and related algorithms. Learn how to classify the types of learning such as supervised and unsupervised learning. Implement supervised learning techniques such as linear and logistic regression. Use unsupervised learning algorithms including deep learning, clustering and recommender systems, RS, used to help users find new items or services, such as books, music, transportation, people and jobs based on information about the user or the recommended item. Learn about classification data and machine learning models. Select the best algorithms applied to machine learning. Make accurate predictions and analysis to effectively solve potential problems. List machine learning concepts, principles, algorithms, tools and applications. Learn the concepts and operation of support neural networks, vector machines, kernel SVM, naive Bayes, decision tree classifier, random forest classifier, logistic regression, k-nearest neighbors, k-means and clustering. Comprehend the theoretical concepts and how they relate to the practical aspects of machine learning. be able to model a wide variety of robust machine learning algorithms including deep learning, clustering and recommendation systems. Course agenda and topics. The basics of machine learning. Machine learning techniques, tools, and algorithms. Data and data science. Review of terminology and principles. Applied artificial intelligence, AI, and machine learning. Popular machine learning methods. Learning applied to machine learning. Principal component analysis. Principles of supervised machine learning algorithms. Principles of unsupervised machine learning. Regression applied to machines learning. Principles of neural networks. Large-scale machine learning. Introduction to deep learning. Applying machine learning. Overview of algorithms. Overview of tools and processes. The basics of machine learning. What is machine learning? Emergence and applications of artificial intelligence and machine learning. Basics of artificial intelligence. Basics of machine learning. Basics of data mining. Data mining versus machine learning versus data science. Data mining and patterns. Why is machine learning important? Creating good machine learning systems. Machine learning techniques, tools and algorithms. Supervised, unsupervised, semi-supervised and reinforcement learning. Basic tools and ideas in machine learning. Supervised machine learning problems and solutions. Supervised machine learning task subgroups, regression and classification. Unsupervised machine learning. Unsupervised tasks and generative modeling. Reinforcement learning, hybrids and beyond. Data preparation capabilities. Techniques of machine learning. Polynomial regression. Linear regression. Random forest. Decision tree regression. Gradient descent and regularization. Classification. Logistic regression. K-nearest neighbors. Data and data science. Principles of data science. Programming, logical reasoning. Mathematics and statistics. Data engineering versus data science. Time series comparison. Neural networks. Steps to machine learning. Review of terminology and principles. Math refresher. Concepts of linear algebra. Probability and statistics. Algorithms. Automation and iterative processes. Scalability. Ensemble modeling. Framing. Generalization. Machine learning methods. Classification. Training and training set. Validation. Representation. Regularization. Logistic regressions. Neural nets. Neural nets. Multi-class neural nets. Embeddings. Applied artificial intelligence, AI, and machine learning. Machine learning prediction with models. Artificial intelligence behaving and reasoning. Applications of machine learning. Machine learning algorithms. Models. Techniques. Statistics in math. Algorithms. Programming. Patterns and prediction. Intelligent behavior. Statistics quantifies numbers. Machine learning generalizing information from large data sets. Principles to detect and extrapolate patterns. Machine learning system analysis and design. Support vector machines. Popular machine learning methods. Supervised learning and unsupervised learning. Supervised learning algorithms and labeled data. Trained using labeled examples. Classification, regression, prediction and gradient boosting. Supervised learning and patterns. Predicting the values of the label on additional and labeled data. Using historical data to predict likely future events. Unsupervised learning and in-labeled data. Unsupervised learning against data that has no historical labels. Semi-supervised learning. Using both labeled and in-labeled data for training. Classification, regression and prediction. Reinforcement learning. Robotics, gaming and navigation. Discovery through trial and error. The agent, the learner or decision maker. The environment, everything the agent interacts with. Actions, what the agent can do. Learning applied to machine learning. Application of supervised versus unsupervised learning. Case study, credit card transactions as fraudulent charges. Self-organizing maps, nearest neighbor mapping, k-means clustering and singular value decomposition. Face recognition. Principal component analysis. Anomaly detection. Deep learning. Neural networks. Learning with deep neural networks. Deep neural networks and hidden layers in multiple types of hierarchies. Deep learning as a type of machine learning. Regularization. Machine learning models need to generalize well to new examples that the model has not seen in practice. Tools to prevent models from overfitting the training data. Principles of supervised machine learning algorithms. Machine learning algorithms mind map. What is supervised machine learning? How does it relate to unsupervised machine learning? Classification and regression supervised learning problems. Clustering and association unsupervised learning problems. Algorithms used for supervised and unsupervised problems. Supervised machine learning as a majority of practical machine learning. Supervised learning problems grouping into regression and classification problems. Principles of classification. Principles of regression. Popular examples of supervised machine learning algorithms. Linear regression for regression problems. Random forest for classification and regression problems. Support vector machines for classification problems. Principles of unsupervised machine learning. The goal for unsupervised learning. Modeling the underlying structure or distribution in the data. Ways to learn more about the data. Algorithms to discover and present the interesting structure in the data. Unsupervised learning problems grouping into clustering and association problems. Principles of clustering. Ways to discover the inherent groupings in the data. Principles of association. Ways to discover rules that describe large portions of your data. Examples of unsupervised learning algorithms. K-means for clustering problems. A priori algorithm for association rule learning problems. Semi-supervised machine learning. In labeled data and a mixture of supervised and unsupervised techniques. Collecting and storing in labeled data. Regression applied to machines learning. Linear regression with one variable. Application of linear regression. Method for learning. Linear algebra review. Refresher on linear algebra concepts. Models with multiple variables. Linear regression with multiple variables. Implement the learning algorithms in practice. Logistic regression. Logistic regression is a method for classifying data into discrete outcomes. Logistic regression to classify a credit card transaction as fraud or not fraud. Principles of neural networks. Neural networks representation. Principles behind neural networks in models. Neural networks learning. Backpropagation algorithm. Learn parameters for a neural network. Implementing your own neural network for credit card fraud. Advice for applying machine learning. Best practices for applying machine learning in practice. Best ways to evaluate performance of the learned models. Large-scale machine learning. Real-world case studies. Interactive visualizations of algorithms in action. Pattern recognition. Accuracy. Case study, marketing campaign. Working with regression. Prediction. Classification. Logistic regression. Unsupervised learning with clustering. Introduction to deep learning. Principles of deep learning. Artificial neural networks. TensorFlow. Learning complicated patterns in large amounts of data. Identifying objects in images and words and sounds. Automatic language translation. Medical diagnoses. Learn more about applying machine learning. Overview of algorithms. Overview of tools and processes. Machine Learning Training Bootcamp. Price, $3,999. Length, 3 days. Call 1-972-665-9786. Visit www.tonex.com web link for more information.